So we've been working on solving quadratic equations using a variety of methods. We started off by solving them by graphing, where we put one side of the equation in y1 and the other side of the equation in y2, and found their intersection. So again, we were using our knowledge of systems of equations to find the solutions. If you had a quadratic equation where you had a single quantity squared, those were great for undoing. If we were able to have a quadratic equation in standard form that equaled 0, we tried using our factoring skills to put it into factored form and then set each factor equal to 0 to find the solutions. Because remember, the two factors multiply to give you to 0. That means one of them has to have the value of 0. So again, take each factor, set them equal to 0 to find your solutions. Another method is called completing the square, where we take our quadratic equation and write it in a way so that it looks like it can be undone. We put it into that vertex transformation format, so we can utilize that undoing method kind of in our step 2 there. If we are unable to use any of these 4 methods, remember we do have one more method to use, and that is your quadratic formula. So again, the quadratic formula, you need to have your equation in standard form equal to 0. You determine your coefficients for the function a, b, and c. A is coefficient of your leading coefficient for your polynomial. B is the coefficient in front of x, and c is your constant. We substitute those values into our formula. We do this very carefully, especially paying attention to the sign value of those coefficients. And we follow the order of operations to evaluate that formula to solve for x. So let's take a look at a couple of equations and see which methods we could use to help solve. The first equation we want to look at is negative 2x squared plus 3x plus 5 equals 0. Let's practice this one with using our quadratic formula. So we can see it's already in standard form. We see it's in descending order from the exponents, and it's equal to 0. So if we're doing the formula, first step is to identify the coefficients for a, b, and c. A is the coefficient in front of our x squared term, so a should be negative 2. B is the coefficient in front of x, which should be 3, and c is your constant, and that's 5. We take these and substitute them into our formula, and again, our formula is the opposite of b going to the right and left, the square root of b squared minus 4 times a times c, all of that being divided by 2 times a. Again, we're just substituting those values into their places of the formula. Now we said, take this in steps and follow your order of operations. So starting here on the left, the opposite of 3, that means we have a negative 3 here. Now I'm going to transition to inside my radical. 3 squared, 3 times 3 is 9, so I'll have a 9 here, and then treat this minus as a negative 4. Negative times a negative is a positive. 4 times 2 is 8. 8 times 5 is 40. So we're going to have a 40 underneath this part of the radical. And in our denominator, 2 times negative 2, well, that would be a negative 4. So that brings us to here. Now again, order of operations, we have to talk about our grouping symbols, and our radical is a grouping symbol. We have 40 and 9 that we have to put together, so we'll have a 49 underneath the radical. Again, looking at the radical, you want to ask yourself, can it be simplified? Is 49 a perfect square, or does it have any perfect square factors? 49 is indeed a perfect square, and its value is 7. So right now we have x is equal to negative 3 going to the left and right 7 units, and all of that's being divided by negative 4. So let's think about going to the left and right that distance. Again, going to the left would be your subtraction, going to the right would be your addition. We simplify each numerator and then compare it to the denominator. So on the left, negative 3, negative 7, that would be a negative 10 over negative 4. Going to the right, negative 3, positive 7, they combine and give you a positive 4 over negative 4. You keep asking yourself, is your ratio simplified? Well, on the left, negative divided by negative, that should be a positive. And 10 and 4 have a greatest common factor of 2 to divide out. So what would we be left with? 5 halves. On the right, 4 and -4, a positive divided by a negative, that's going to be a negative, and there's a greatest common factor of 4 for each part of my ratio, so this will simplify to -1. So my two solutions are -1 and 5/2. So that's a way that we could use the quadratic formula to find our solutions. Now, if we look at our equation, some of you may have said, well, is there another way that we could have solved it versus using the quadratic formula? And in particular, most of you kind of started looking at the factoring option. So we could take and see, is there a greatest common factor to divide out? If not, take that leading coefficient times the constant. And try that method, we would have what two numbers multiply together to give you -10, but add to give you a +3. And we do know there is a number combination that works for this. We could use a +5 and a -2. So if we do that, and we wrote it out with our four terms, we could try factoring by grouping now, using that +5 and the -2. Again, the way that I have it arranged here, I could divide out a -2x from my pair on the left. I could divide out a 5 from my pair on the right. And notice how I'm left with each pair having that remainder of x plus 1. So one factor is going to be x plus 1. The other factor could be -2x plus 5 equals 0. Again, looking at your factors, we take each factor, set them equal to 0, and solve. So I could have x plus 1 equals 0 and -2x plus 5 is equal to 0. We undo each of these equations to solve for x. So on the left, we would subtract 1 from each side, and on the right, there's two steps to do. We'd have to subtract 5 and then divide by -2. Again, resulting in your answers of -1 and 5/2. Let's try this equation. We want to solve 4x squared equals 3x minus 3. As we look at this equation, we know that we cannot undo it because we have more than just a quantity squared, but let's put it into standard form to see what other options we have available to us. So for me, to put it into standard form, I'm going to subtract 3x and add 3 to each side of my equation. Now, as I look at this, my options could be factoring, quadratic formula, completing the square. I probably wouldn't want to do because if I need to do that method, I have to have a leading coefficient of 1, and that would be a lot of steps. Graphing it, I could do with the technology, but I'd have to adjust the window. So let's see if we could factor it or use the quadratic formula. Those would probably be the most efficient ways of our time. Factoring wise, I'd have to think about, are there two numbers I can multiply together to give me 12 and add to give me a -3? And I know with my options for multiplying to get 12, none of them will combine to give me a -3. So factoring's off the table. This one, if we do our quadratic formula, A is 4, B is -3, and C is a +3. I'm going to take those and put them into my patterns. Remember, x equals the opposite of B, going to the right and left, the square root of b squared minus 4 times a times c, all of that being divided by 2 times a. So if we substitute our pattern, our values into our pattern, this is where we end up. Now we just have to do the order of operations. So the opposite of a negative is going to be a positive. I'll have a +3 here. If I go to my denominator, 2 times 4, I'll have an 8 there. Inside my radical, -3 squared. Now remember, that means -3 times -3, that would be a +9 right here. A negative times a positive, that will be a negative. 4 times 4 is 16, so I've got a -16 times a +3, that would be a -48. So right now I have x is equal to 3 right and left, the square root of 9 minus 48, all of that being divided by 8. The radical is the grouping symbol, and symbol, and we want to simplify as much as we can. So if we have a positive 9 and a negative 48, that would simplify to be a negative 39 underneath the radical. So we've been practicing simplifying radicals, so we want to say, okay, since it's negative, we have to think about rewriting it so it's somehow partly positive, and then go from there. So we're going to think about this as writing it as the square root of a positive 39 times the square root of negative 1. The reason why I want to do that is now we can focus on simplifying the radical of positive, and we remember that the square root of negative 1 is represented by I. So we're going to have an I here in place of the square root of negative 1. Now, 39, is that a perfect square, or does it have any perfect square factors? You can look at your table of perfect squares and see where that falls, and then work your way back to 1 to find the largest perfect square factor. Unfortunately, 39 is not a perfect square, nor does it have any perfect square factors, so we're going to have to leave it as is. So here we are. We've got x equals 3 right and left, I, times the square root of 39 divided by 8. So at this point, we have to say, well, is there any other simplifying that we can do? To help us think about it, let's talk about going to the left and right. So let's write them separately to see if there's any other simplifying that can happen. So going to the left, that's your subtraction. Going to the right is the addition. And remember, the numerator, we can compare each piece of the numerator with the denominator to see if there's anything to divide out. So this 3 compared to 8. Do 3 and 8 have any greatest common factors other than 1 that we can divide out? They don't. Then we're going to look at the second piece, that negative I squared of 39 over 8. Do they have any like pieces you can divide out? And again, we have to be looking at the exterior of the radical to see if that is the case. And that isn't. So that is as simplified as can be. If you look at the right-hand side, same idea. Compare your 3 with your 8, no greatest common factors. Compare your positive I squared 39 with your 8, any common factors there that you could divide out? There's not. So we've got our two solutions in their final format. We talked about how you can write them as two separate solutions like we have here, or you could condense it as one. Like we have at the step above, they are still communicating the same two imaginary solutions for this quadratic equation. And again, we should have anticipated that we'd have imaginary solutions because looking at the discriminant, the value underneath the radical, we saw that it was less than 0. So that was our clue to anticipate having imaginary solutions, an I, within our answers. Let's try one more equation. Here we want to solve 3x plus 8 is equal to 7x plus 3x squared. Now for this one, what I would do is we have some like terms. Let's write it in standard form, and then we can evaluate it from there. How you write it in standard form is up to you, whether you like having a leading coefficient that's negative or positive. It does not matter, just make sure that everything is on one side of the equation. So what I'm going to do is I'm going to have a leading coefficient that's positive, so I'm going to take everything on this left-hand side and move it to the right. So I'm going to subtract my 3x, I'm going to subtract 8, giving me 0 equals 3x squared plus 4x minus 8 to work with. Now, as I look at this, I can see if I could factor it, right? Any greatest common factors, or if I take my pattern of the leading coefficient times the constant, are there two numbers that we can multiply together to get 24 and add to get 4? If I can, that would probably be the quickest way to get to our solution. If not, then maybe we want to implement our quadratic formula to help us. Thinking about your factors of that negative 24, unfortunately, we're not going to be able to make a positive 4 with them. So we're going to have to do our quadratic formula. So we're going to have to identify our A, B, and C values. For us, A is 3, B is 4, and C is negative 8. We're going to take those and substitute them into the pattern. So again, the quadratic formula, x equals the opposite of B, right and left, the square root of b squared minus 4 times a times c, all of that divided by 2 times a. Now we just have to implement our order of operations to find the solutions. So going from the left there, the opposite of 4, that would be a negative 4. On the denominator, 2 times 3, that would be 6. Let's focus under the radical next. 4 squared. 4 times 4 is 16. Negative times a positive is going to be a negative, and 4 times 3 is 12. So we have a negative 12 times a negative 8. Well, that will become a positive, and we've got that now going to be a 96. So writing in those simplified pieces brings us to here. We still have some simplifying under the radical to do. 16 and 96, well, that gives us a value of 112. Again, with radicals, you always want to put them in their simplified format. We're not using decimals, simplified radical form. So does 112 have any perfect square factors, or is it a perfect square itself? As we look at our table of perfect squares, we see where 112 lies. Work your way back towards 1 to see what's your largest perfect square factor. Our largest perfect square factor here is going to be 16. 16 times 7 gives you 112. So let's rewrite it using that largest perfect square factor. And again, we know the value of the square root of 16 is 4. So what are we working with now? We have x is equal to negative 4 going to the left and right, 4 square root of 7, all of that being divided by 6. At this point, we want to see, is there any other simplifying that can happen to help get our solution? And so again, we want to compare each element of the numerator to the denominator. So if it helps you write them individually, go ahead and do that. We need to compare negative 4 to 6. And then we know we are going in each direction. So if we think about going to the left, let's do our subtraction. We're going to have 4 square root of 7 over 6. Well, a negative divided by a positive, it's going to be a negative. 4 and 6 have a common factor of 2. So what would we be left with? We would have 2 over 3. Now the second piece, a negative divided by a positive, that's going to be a negative. And again, 4 and 6 have a common factor of 2, so we'd have a 2 and a 3. Notice how the denominators are the same. So we could say by going to the left, we would have a result of negative 2 minus 2 square root of 7 over 3. Same idea could be done for going to looking to see what we can divide out from each term. So again, here, negative divided by positive, that's a negative. They have a common factor of 2 to divide out. Positive divided by a positive, that's a positive. 4 and 6 have a greatest common factor of 2 to divide out. So what were we left with? We have negative 2 plus 2 square root of 7 over 3. So we've got these for our values for x. And if you notice, they're very similar, except one's going to the left, the minus, and one's going to the right, the plus. So could you condense it and write it as one expression? Sure you can. You could write it as negative 2 going left and right. So you got your plus minus 2 square root of 7 over 3. And again, we'll show you what that looks like here if you choose to do it. Otherwise, leave the two separate results as is.